Have you ever wondered if Earth could survive a close encounter with a black hole? Not in some distant galaxy, not billions of years from now, but one heading directly toward our solar system. At first, you probably imagine the sky turning black as a giant cosmic monster swallows the planets one by one. Movies love that image, but reality is stranger, and in many ways, far more terrifying, because a black hole doesn't need to touch Earth to destroy civilization. Long before we ever reached its event horizon, its gravity could quietly begin rewriting the solar system itself. The planets could drift from their familiar paths. Comets hidden for billions of years could suddenly rain inward. Earth's seasons might become unpredictable. Oceans could rise and fall in impossible ways. And by the time humanity realized what was happening, it would already be too late. So if a rogue black hole were actually coming toward us today, how long would Earth survive? Before we answer that, we need to clear up one of the biggest misconceptions in science. A black hole is not a giant cosmic vacuum cleaner. If you replaced our sun with a black hole of exactly the same mass, every planet, including Earth, would continue orbiting almost exactly as it does today. The only difference is that we'd instantly lose sunlight and eventually freeze. The gravity itself would remain virtually unchanged because gravity depends on mass, not whether that mass is a star or a black hole. That surprises most people. Black holes don't magically suck everything across space. They're simply objects whose mass has been compressed into an unimaginably tiny region. Their gravity only becomes overwhelmingly destructive when you get extremely close to them, which raises an even more unsettling question. If black holes aren't cosmic vacuum cleaners, how could one still wipe out Earth? The answer lies in something much more subtle: gravity. Imagine astronomers discover a dark object moving through interstellar space. It emits almost no light, no visible surface, no glowing atmosphere. Only one clue gives it away. Stars behind it appear to shift ever so slightly as its gravity bends their light, a phenomenon called gravitational lensing. After months of observation, scientists calculate its mass, around 10 times heavier than our sun, a dormant stellar mass black hole. Even worse, its trajectory points directly toward our solar system. Panic spreads across Earth. Governments demand answers. Could we stop it? Could we move Earth? Could we even survive? Unfortunately, space doesn't negotiate. Fortunately, space is unimaginably large. But detection isn't the same as protection, because once gravity takes over, there is no shield, no weapon, no technology capable of pushing away something with the mass of multiple suns. The first victims probably wouldn't be Earth. They'd be the frozen outskirts of our solar system. Far beyond Pluto lies the Oort cloud, a vast spherical shell containing trillions of icy objects left over from the birth of the solar system. Most have remained undisturbed for billions of years, until now. As the black hole passes nearby, its gravity begins disturbing these ancient objects. One by one, then thousands at a time, entire swarms of comets start falling inward. Humanity witnesses spectacular new comets filling the night sky. At first, the public celebrates. Astronomers don't, because every beautiful comet represents a warning. The solar system is beginning to lose its balance. Months or years later, the effects become impossible to ignore. Precise measurements reveal tiny changes in planetary orbits. Nothing dramatic, at least not yet. Mercury shifts slightly. Mars arrives fractions of a second early. Saturn drifts by a barely measurable amount. Individually, these changes seem insignificant. Together, they're catastrophic. Planetary orbits are like an enormous cosmic clock. Every planet influences every other through gravity. Disturb one gear, eventually the whole mechanism starts slipping. And that's exactly what's happening. Humanity isn't being attacked by the black hole itself. We're watching our perfectly balanced solar system slowly unravel. Then comes the moment every observatory feared. The black hole crosses inside the outer planets. Now its gravity becomes impossible to ignore. Jupiter, the solar system's giant guardian, begins experiencing measurable orbital disturbances. That matters more than most people realize. Jupiter's enormous gravity has protected Earth for billions of years by redirecting countless asteroids and comets. But now, the protector itself is being pulled off balance. Suddenly, thousands of new trajectories become possible. Asteroids that never threatened Earth now do. Comets once safely trapped beyond Neptune begin diving toward the inner solar system. Humanity finds itself fighting multiple extinction-level threats simultaneously, and the black hole still hasn't come anywhere near Earth. By now, every telescope on Earth is locked onto a single target. The black hole is no longer just a distant astronomical curiosity. It has become humanity's countdown clock. As it moves deeper into the solar system, the consequences escalate dramatically. The gravitational tug on Earth becomes measurable. Not enough to rip the planet apart. Not yet. But enough to subtly alter our orbit around the Sun. At first, the changes seem insignificant. A slightly longer year. Tiny shifts in Earth's distance from the Sun. Small changes in the timing of the seasons. But Earth's climate is built on extraordinary balance. The threat is no longer theoretical. Civilization itself begins to strain. Then comes another invisible danger. Tidal forces. Gravity doesn't pull equally on every part of an object. The side closest to a massive body experiences a slightly stronger pull than the far side. On Earth, this difference creates our ocean tides because of the Moon. A nearby black hole would create tidal forces on an entirely different scale. The sky itself would become unfamiliar. The Moon's orbit could change. Artificial satellites would struggle to remain stable. Space stations might require constant orbital corrections simply to stay aloft. Every system humanity depends upon, from GPS navigation to global communications, would become increasingly difficult to maintain. Now imagine the worst-case scenario. The black hole isn't just passing nearby. It's heading directly toward Earth. Contrary to popular belief, Earth wouldn't instantly disappear. The first truly catastrophic effects would come from tidal gravity. As the black hole approached, the difference in gravitational pull between Earth's near side and far side would increase dramatically. Mountains would crack, oceans would surge, the planet's structure would begin to deform. Eventually, Earth would cross a boundary where gravity becomes overwhelming. This is where one of the strangest phenomena in the universe begins: spaghettification. Despite its almost humorous name, it's one of the most terrifying processes known in astrophysics. Everything stretches. Fortunately, or perhaps unfortunately, for a stellar mass black hole, Earth itself would be torn apart before anyone could experience much of this directly. The planet would break into molten fragments, spiraling toward the event horizon. Nothing that once resembled Earth would remain. But here's something even stranger. If the black hole were supermassive, like the ones found at the centers of galaxies, the experience would actually be different. Because supermassive black holes have much larger event horizons, the tidal forces at the edge are surprisingly weaker than those around smaller black holes. In theory, an object could cross the event horizon of a supermassive black hole without immediately noticing anything unusual. Of course, escape would still be impossible. Once inside the event horizon, every possible path through space and time leads only one way, toward the singularity. No rocket, no engine, not even light itself can reverse that journey. So, could humanity escape before any of this happened? If we had centuries of warning, perhaps a small number of people could attempt to establish colonies elsewhere. Mars, the moons of Jupiter, even interstellar generation ships. But moving 8 billion people off Earth? With today's technology, that's impossible. Even transporting a few million people would require industrial capabilities far beyond anything humanity has ever achieved. And if the black hole's arrival were measured in decades rather than centuries, there would simply be no time. Our survival would depend less on engineering and more on luck. Fortunately, there's some reassuring news. Astronomers have found no evidence that a rogue black hole is currently on a collision course with our solar system. The Milky Way certainly contains millions of stellar mass black holes, but space is unimaginably vast. The chances of one passing close enough to threaten Earth anytime soon are extraordinarily small. Still, scientists continue searching, not because they expect disaster tomorrow, but because understanding these invisible giants helps us understand the evolution of stars, galaxies, and gravity itself. Every new observation makes our picture of the universe a little clearer. In the end, a black hole doesn't need glowing eyes or cosmic explosions to inspire fear. Its greatest weapon is something we experience every second of our lives: gravity. The same force that keeps our feet on the ground can also tear apart planets, bend light across the universe, and trap time itself. If a black hole ever did wander into our neighborhood, humanity probably wouldn't vanish overnight. Instead, we'd witness the slow collapse of the delicate gravitational balance that has protected Earth for more than 4.5 billion years. And perhaps that's the most unsettling thought of all. The universe doesn't need monsters to end a civilization. Sometimes, the quiet pull of gravity is enough. If this journey changed the way you think about black holes, subscribe for more scientifically accurate space documentaries. And if you could learn the answer to just one mystery of the universe, what would it be? Let us know in the comments, and we'll see you in the next exploration beyond the edge of the known universe.